Hi everyone! Today I will show you how to detect an interior furniture with Yolov5 in Google Colab. So let's begin. First, we have to set up some requirements. So the first thing that we need to do is to clone the Yolov5 repository. The Yolov5 repository is this. So we need to clone it in the Google Colab. So when the clone is finished, we see a folder named Yolov5 like that. So when it is finished, we enter in the folder with that command. We install the dependency and we install the Roboflow package just for loading the dataset after. And we need also to download the package of ImageIO FFmpeg just to read the video after. And when it is finished, we have to import the torch library just for the Yolov5 again, and just the OS and some package for the display of images. And after that, we have to set up the Roboflow model. We just import the Roboflow and specify the model format or in Yolov5 and the notebook name. And after that, we set up the dataset directory that we will see after. So when all of that is finished, we can now get the dataset from Roboflow. So, but before we get datasets, we need an API key like that. So to add this API key, we need to have a Roboflow account. So to do that, we have to sign up in Roboflow, and you will have a dashboard like that, and you go to the workspace setting and Roboflow API, and you will see your private key here after clicking to show. So when you have your API key, you can run this command to download the dataset. So when the download is finished, you see a folder dataset like that. After, we can now train the YOLO model. So to train it, we have to specify something like the image. For that dataset, we need 640 pixel and a batch size of 16, an epoch of 100, and the YAML data. So just for the YAML data, I have to precise one thing. The structure of the data is like that. So the train means the path of the train data. The val is the validation data. The test is the test data. The NC is the number of labels, and the name is the list of the labels. And after that, we also see the Yolov5 s.pt. This is the Yolov5s, that means small, because there are a lot of model, but we use the small model here. And the last parameter is the cache, is just for making something very good, very to speed up the training. Okay, so we run that and we have the training like that. And after that, we will see the training, and after we will see the training result with TensorBoard. So as we see, the MAP is increasing till 0.794, and I just want to precise that the MAP is the mean average precision. So when it is finished, we can predict the images. So we predict with that command. We say we just use the best point PT is the best model that we have trained, and we process the images and the location of the images, and yeah, it's like that. So we predict it, and this is the result. We see that for the window, we predict the window of the left with a probability of 0.8 and the window of the right with a probability of 0.77. And after that, we try to predict images or image of bed, and we see that it have a probability of 0.66. And after that, we try to predict a chair, and we see that we have a probability of 0.5. And after that, we try to make a prediction of a closet, and we see that we have 0.81. And we do the same things with shelf, and we see 0.84. And now we try to predict this many label in the same time. So now we see that the sofa is with a probability of 0.47 and the door is 0.36. We see that the probability is a little bit small because we don't see all of the images of the sofa, and it's the same for the door. But for the table, it's the probability is a little big because we completely see the table. And after that, we try again with a computer and a monitor, and we see that the probability is good for the computer and the monitor. And at the end, we try to predict a video, and with the same command like before, but we just make the path of the video that I have uploaded here. And we can see, just for precision, we need a custom function like that just for displaying in Google Colab. It's just for Google Colab. And we can now load and display it, and there is the result. We see that we can predict the shelf so far, and we see the prediction of a window. Okay, so that's all for today. Thanks for watching.